Next on the topic is your stacks. Now, what are stacks? Stacks are ordered list where you can insert and delete only at the top. So you can perform it only on the top. It works on the last in first out policy. That means the last element which has entered, it is the first element that will move out. The application of stacks are recursion, evaluation, parsing, browsing, editing, tree traversal. There are various operations that can be performed on a stack. What happens in stack is that whenever we push an element, pushing the element means we want to add an element, so we can push it on the top. Again, when we take out the element, it has to be from the top only. That's the reason it's called as last in first out. Since it is the last element that has been entered, so it is the last element to move out. It's last in first out. As you can see in this example, in this 93 is our top. If I want to add an element 10, which is called a pushing operation, now this 10 will become my top. Now when I want to pop, means take out the element, this 12, the last element only has to pop out. So that, and then again my top is updated. Pick is suppose we want to look what are the values available in our uh, list. In that case, we will be using pick command. Pick is to look at the elements without removing them. Now, in a stack, initially the stack can be empty. If the stack is empty, at his stage, the topmost element will have the value as -1. This is a convention used in C, isn't it? In stack, at this stage, the value of the top will be -1. As you can see over here, the stack is empty. If the stack is empty, the top will have a value of -1. When the stack is not empty, suppose we put elements to the it. In that case, if this is -1, if this was -1, then this is 0, 1, and 2, and this is having 2. The top is 2 because initially the top was -1. Initially the top was -1, and now since there are then it became 0, then it became 1, then it became 2, because there are 3 elements, so the top becomes 2. While deleting the data from the stack, the last element which has entered will move out. As you can see over here, this 10, 7, 9. 10 is at the top, so when we pop out, it moves down. We can perform stack with the help of array. Array can be used. Adding an element on the top of the stack or 2s push, as I already told you. Now stack is overflown when we try to insert an element into a completely filled stack. Suppose the elements in this, all of them are having some values. All of them are having some values. Now if I want to add value on it, how will I add it? Because it is having all the data, it will not pop out automatically. Therefore we have to check this whether the stack is empty or it's full. This is one of the check that needs to be performed. The push operation, see, here I have written the operations, see, in a single order. I'm giving you just a subcode over here. Now you must understand that if you directly copy this code and paste it in your compiler, then it will not work. It is just a part of the entire code. The code is also given, don't worry. You can write your own code, or can just analyze the code which I have given to you. In the push operation, we first need to see whether the stack is empty or full. Now if my top is equals to n, that means my top is having the highest values. As I told you, top starts from -1. Top starts from -1, then it adds on. If it is completely full, in that case it will tell you it's overflow, so we cannot add more data. If it is not, then top will be implemented. Initially it is empty. Initially my top is what? Top is -1 when it is empty. Now if I want to add the first data, suppose this is empty, I want to add the first data over here. If I want to add the first data, then I have to make it 0. Top has to be 0. That's the reason we have added 1 to it. It becomes 0. Now we're putting the value over here. Similarly, while popping out in, that is while deleting the data, we must check whether, I mean, the data, whether there is any data present or not. Suppose in your stack it is completely empty stack. If it is an empty stack, then what is the value of top? The value of top is -1. Now if it is -1, that means top is -1. If my top is -1, that means I have no value in my stack. If I have no value in my stack, then what will I pop? Hence it will check whether there is anything available or not. If not, then it will pop. If it is available, then it will pop it out and it will just decrease top. Top minus minus means what? Top minus minus means that, suppose right now I had one value. Suppose I had a value. I had a value of 1. If I had a value of 1, what is my top now? Initially, top was initially 0, and since I popped it out, since I popped this 1, now my top has to decrease to -1, and that's the reason you did -1. Peak operation, it involves just returning the value which is present on the top. It will just show you without deleting it. That's the important point. It will not delete it, it will do nothing, it will just find out the values. So peak operation also, if peak is -1, then it is underflow. That means there are no values available. If it is not, then it will show you the topmost value. So peak is, why peak is required? Peak is required to see what is the most value available. This is the entire code. You can just copy paste the code, or you can write your own code. It doesn't matter. I have written it in C. You can use C++, Java, Python, anything you want. There are 3 operations that we are showing: push, pop, and show. Show is basically the peak operation. Since I'm using array, so I have to predefine it. Here I'm predefining this stack as 100. Initially, you will be asked to give a choice among the 3: push, pop, show, and exit. Depending upon your choice, you will be taken to that particular code: push, pop, show, and exit. So push, I've already explained you the push operations, how it works out. Similarly, I've explained the pop operation. Now this stack, it can also be implemented with the help of linked list. We have already discussed linked list in the last videos. Advantage of linked list is that here memory allocation is dynamic. As you can see in array, you have to predefine it. Here I have predefined, I have given a very large value. Now suppose out of hundreds available values, only 5 are being used, then 95 of the memory locations are being misused, isn't it? And that's the reason if stack in linked list is useful. Why? Because in linked list what happens is that linked list consists of nodes. It consists of single nodes. It can, if it is singly list, then it will have node consisting of 2 parts. One is data, another one is your data, and another is your address. If it is a doubly linked list, then it will have 3 parts. It will have data, and it will have previous address and the next address. The time complexity, there is a time required to perform the operations are same in both the cases. So preferably it is good that you be use linked list method. As I told you, in the linked list method, it will point out to the next data. So it will point out to the next data. It's a dynamic allocation. Stack always follow last in first out. That is the last value which I have entered, it will first pop out. The topmost node in the stack always contains null in its address. Why? Because it is not going to post anything. Topmost, suppose you have a value, you have 3 data, you have 1, 2, and 3 data. Now this node will have my, as I told you that in a linked list, the last node will have null. Isn't last node will have null, and in a stack, which is the last value? The last value is this. The topmost value is the last value. Hence, the topmost value will have null. This address. The rest things are same only. Adding operation or deleting operation. Here only adding an operation, adding and popping out is done through nodes. If I use W linked list, then I will have the last node and the next node. Now you see, suppose this is the original value. Here I have given it, this is node 1, this is node 2, this is node 3. I have some value 1, I have a value 2, I have a value 3 over here. Now I want to add another node. I want to add another node, isn't it? Then what will happen? Initially, this header was pointing this, but now this header will not point this. The header will point to my new node. This is my new node, and the new node will now point to this node. Hence, what will be the address present at this? This is the topmost value, isn't it? I believe you've understood it. Initially, it was having three nodes. Now I added the next node. If I add the next node, then the header will point to the new node, and the new node will point to the last. There. Um, as I have told you, in a linked list, it is a dynamic allocation. Hence, initially you will write size of to determine the size, and then you will use malloc in order to give it a dynamic allocation. This is a pointer. Initially, if the pointer is null, then you will not be able to push any value. It means there is no space available. Then what will you push? Else you will take the value, and as I have told you earlier, your nodes will have a data value and will have an address value. So pointer will once put the data to the data value and the address to the address location. As you can see over here, it is putting the data to the data value and the address to the address location. Similarly, we have a delete operation, and you have the display operation. The entire code is present over here. I am having push pop and display operation. Please go through the code. If you face any problem, then just message me in my WhatsApp number. Next we have the queue. Now the queue can be defined as an ordered list, and where we can insert the element in the rear end and delete the elements from the front end. Now queue follows first in first out policy. It is example when, for example, people waiting in a line in the railway line. The first person who is on the line, he will get the ticket and he will move out. So it's first in, first out. The front, as we have told you, we add element in the rear end, and we add element in the rear end and it moves to the front and it moves out from the front end. So we add at the rear end, we add at the rear end, we move out from the front end. Application of queue. Queue are widely used as a waiting list or single shared resources. Suppose you have a printer. You have a printer and 10 people are trying to print the individual files at the same time. So who the first person will get because the printer can only print one page at a time, isn't it? The first person who has a click print will get his data will get printed out. So in this type of system where we have a single shared resources, we used queue. Queues are also used for asynchronous data transfer, where data is not being transferred at the same rate between two processors. Queue are also used as a buffer in most of the applications like FTP player, all while making the playlists. So basically, queue is a type of data structure where the first element that enters will first go out. I have already explained you this. The first element which is entered will first move out. It enters at the rear end and moves out from the front end. The operations of queues are basically there are two operations, NQ and DQ. NQ is the operation of inserting the element, DQ is the operation of leaving the element. Apart from that, you can also have the peek operation where we return the elements which is present at the front, but it does not delete it. In just like the stack in the queue, also we need to check overflow and underflow. Overflow is that when the queue is completely full. If the queue is completely full, then you cannot add any more elements, so that is overflow. And if the queue is completely empty, then you cannot move out anything. It's underflow. So there are two ways of allocating. It can be sequential allocation, or we can use linked list. What are the, as I have already discussed you, queue is used for share in place where we need to share resources, we use queue. Here the request that arrives first, the queue will be served first. As in the printer, out of the 10%, the first person who has applied for the print, his page will get printed out. There are four types of queue. Linear queue. A linear queue, here the insertion takes place at one end, while the deletion occurs at the another end. That's a linear queue. It strictly follows the FIFO rule. So what happens over there is that, suppose this is my queue, this is my queue, and the first value which is entered is the first is move out. So it strictly follows the FIFO policy. Then we have a circular queue, similar to the linear queue. In the circular queue, the only exception is that the last element of the queue is connected to the first element. So the last element of the queue is connected to the first element. So here no underflow overflow concept is applied. It's also known as the ring buffer. So you can represent that in this manner. The last element is also connected to the first element. So it's a circular queue. The drawback that occurs in the linear queue is overcome in the circular queue. We also have a priority queue. What is a priority queue? In priority queue, each element will have some sort of priority associated with it. And based on that, that will be served. For example, in a traffic jam, who will get the first priority? Obviously, an ambulance will get the first priority, isn't it? So that's kind of things. In the queue also we can give priority, and if we give priority, then based on the priority, the elements will be sorted. The elements will be perform the operations. Now, if the element occurs with same priority, then we will serve in the FIFO policy. We can use array to represent the queue, or we can use um, linked list in order to represent the queue. Addition deletion is same, just like a stack. So go through the code. If you face any problem, do inform me. I will explain it. So this is the basic code. Just like any other thing, here also we have our insertion, deletion, and display. Front will have -1 in this. Remember, in the stack we had top as -1 initially. Here front will have -1 initially. Here will have -1. Now the reason for this is that if you remember what happens, what is the first element in an array? The first element in the array is placed in A0, isn't it? The first element is present in A0, and that's the reason we start with -1, because we want to add the first element. It -1 represents empty. We want the first element, we will add +1 to it. So we'll make them 0 0. We'll make it 0, and then we will add the values. So this is how it works out. What is the drawback of array implementation over here? It's a wastage of memory allocation. I have already explained to you that in array what happens is that we have to predefine our array. So suppose I initially have to tell you that the array is a size of 100. If I tell you array size of 100, then if size of 100 memory location will be fixed. And out of this 100, if I only use 5, then 95% of the memory location is being wasted. That's the reason array implementation is not so much relevant. In place of array implementation, nowadays we generally use linked list implementation, where we have nodes and one node is connected to another node depending upon our requirement. So it's a dynamic allocation. I have already given you the codes, and this PDF will also be provided to you. Go through them. If you face any problem, this is the entire code which is based on linked list. Go through the code, go through them. If you face any problem, just inform me. It's an insert. Again, we will have a structure. Structure will have a pointer. Since I'm using linked list, so I will have a data. I will have address. Address is stored in pointers. Data is stored normally. We will check whether it is null or not. If it is null, that means it's overflow. We cannot insert anything. If it is not, then we will take the data item that we need to add. We will put it on the data and we will update our pointer as well. Thank you.